is Gerardo Morell. I'm the director of the Puerto Rico Space Grant Consortium and the Puerto Rico NASA EPSCoR programs. Let's see. So let me talk a little bit about the Space Grant and the NASA EPSCoR programs as a way of giving like a background of what we're talking about. Okay, so Space Grant is a NASA program. It's created by Congress, so it's a congressionally mandated program run by NASA. And there is a Space Grant Consortium in each one of the 50 states and 2 jurisdictions, or 2 territories, Washington DC and Puerto Rico. So there are 52 consortia or Space Grant Consortia across the nation. So wherever you go in the US, there is a Space Grant locally in your jurisdiction. And I invite you, those of you who are not from Puerto Rico, to also make contact with your local Space Grant Consortium and participate in the activities and with your expertise and your experience or whatever capacity that you can contribute to the activities of your Space Grant Consortium. So, in Puerto Rico, the Space Grant Consortium includes 15 affiliate institutions. Of course, we have the engineering schools, and we have most of the UPR campuses are part of the consortium. Also, private institutions like Inter-American University and the Ana Jiménez University system are part of the consortium. The EPSCoR that Ada was talking about this morning, Starbase Puerto Rico, the Puerto Rico Astronomy Society, among other members also of the consortium. The idea is that they are distributed in all geographical areas of Puerto Rico, and they reach out to all the socioeconomic levels and all the population in Puerto Rico. So along with the Space Grant Consortium, the director of the consortium also, in those states where there is the EPSCoR program, we run the NASA EPSCoR program. So if you have the Space Grant hat in your jurisdiction, and your jurisdiction happens to be an EPSCoR jurisdiction, then you are also the director of the NASA EPSCoR program for your jurisdiction. And these are the 29 jurisdictions that are under the EPSCoR program. For those of you who don't know what the EPSCoR program is, this program initiated in NSF in the 80s, and then the Congress extended this contract to other agencies. And it's essentially those jurisdictions that receive the least amount of federal dollars for research. And the Congress then assigns funding for research to be competed for among those EPSCoR jurisdictions. So you have not only Puerto Rico, you have Mississippi, the Dakota, South Carolina, Hawaii, among other states that you can see in the map. Okay? So now let's concentrate on NASA EPSCoR and the projects within NASA EPSCoR that are running or were run at the International Space Station. NASA EPSCoR is divided in different types of awards. We have the SIG funding, the Rapid Response Research, what they call the Research Awards, and also the ISS Award. So we have 4 different categories of awards within the EPSCoR program. Okay? And we run these competitions every year. We run a cycle for these programs. It's a 2-tier process. First, you run it at the jurisdiction level, and then proposals are sent by the jurisdiction directors to the NASA headquarters for the national competition. First, talking about the rapid response research, in this particular competition, you can request up to $100,000 for 1 year. So it's It's a one-year project that maybe you can go for a second year if you do a no-cost expansion. The topics under the rapid response research are defined by the agency. So there are scientists and engineers who suggested a topic of their interest on a particular issue that they are trying to solve, and they are seeking the help of the EPSCoR jurisdiction in solving that problem. And so the scientists and the researchers in the jurisdictions are given the opportunity to write a small proposal, typically 5 to 6 pages, that they can also do in conversation and collaboration with the source of the topic. So they can contact the person and fine-tune exactly what is it that they need and what is it that we can do at the academia in the different EPSCoR jurisdictions in order to propose something that makes sense and that will be helpful for the agency. And so we run this competition every year, and each EPSCoR jurisdiction can submit up to 6 proposals in each competition. The PI can only be, in all of them I am the managing PI as required by the agency. The EPSCoR director of the jurisdiction will be the management PI. But then there is the counterpart to that is the science PI. So we can have 6 different science PIs submitting 6 different proposals to the agency each year under this category. And this is a great opportunity to start collaborating with NASA scientists and engineers on topics that we know are important to the agency. Then we have this is the list of the currently running rapid response research projects in Puerto Rico. We have 5 such projects in different stages of development in Puerto Rico right now. Then going to the research awards. In the research awards, you can apply for up to $750K from NASA to be matched 50%, $375K from the jurisdiction. So in this case, matching is a requirement, okay? And then the focus is that you have to work on a project that is directly tied to the NASA mission, but it's also important for the jurisdiction. So it has to have both components. Not only because the review process will require it, but also because you are getting matching funds. So if you are getting matching funds, it is expected that you are working on a project that is not only important for the agency, but is also contributing to the research infrastructure development locally in Puerto Rico. Okay, and we run this competition every year. Right now, this notice of funding opportunity is open, and we are running the local competition. Until December 15, we are receiving what we call the pre-proposals. It's only a 5-page white paper. And then, with the help of our advisory board, we have to select one proposal that will be submitted from Puerto Rico to NASA in February. Okay, so we will be telling, by the end of December, we will be telling the researchers who is selected to submit the full-fledged proposal to NASA. And this is the list of the currently running research awards in Puerto Rico. We have 5 such awards running in different campuses of the UPR system. So far, we haven't got the private institutions in Puerto Rico to provide the matching funds, and that's why we don't have any private institution participating so far in the research award competition. The UPR has been, the President's Office has been providing the matching funds for these NASA EPSCoR projects during the last 10 years. And then we have the ISS awards. This is like a more mature stage of the research. You probably did the seed funding, or you did the rapid response research, or the research award, or you got funding through other mechanisms from NSF or DoD to run projects in your laboratory. And finally, you find out that your project is developed enough that it deserves to be tested in microgravity. Okay? So this is the later stage of a research project, be it that it was funded by NASA in the earlier stages or not. But most of the time, they did get some funding in the earlier stages from NASA, specifically from NASA, what we have seen so far. The idea is that now you have a project that is working on the bench, and you feel that these can have some space applications and it need to be tested in microgravity. So this is what the ISS EPSCoR competition is for. You can apply for $100,000. We have this competition every year, and you have to show that your experiment requires microgravity environment for testing. And in this case, the $100,000 is only for the final payload fabrication and the adaptation of the payload to the constraints of the ISS. Because as I mentioned, you already know the experiment works on your bench, but now you have to make the adaptations of your experiments into a payload. That's what this funding is for. In addition to that, which is not accounted for in the 100K, you have the implementation costs, which are provided by a private company, which is in this case selected by NASA. That funding is much more than $1 million, but you don't have to budget for that. If your proposal is selected, you will get a 100K for your payload fabrication, and NASA will provide the implementation, the funding for the implementation of your payload into the ISS. And then I want to describe a little bit of these projects that we have been sending from Puerto Rico to the ISS. The first one is for the electrochemistry, electrochemical experiment in microgravity. Essentially, they were oxidizing ammonia using platinum nanoparticles. This is an experiment done in Dr. Cabrera's laboratory, and we have Camila Morales, was the doctoral student who was working on this project, and she graduated with this as her thesis research. It was launched in 2020 from Wallops, and they had actually done prior research using the parabolas in an airplane, and they found that this oxidation of ammonia changed if you were under short periods of microgravity conditions in the parabola. And so they had the case already to go to the microgravity environment in the ISS and see what is actually going on. Why is this oxidation of ammonia being affected by microgravity, and how to mitigate that, okay? And you can see there the curve of the same experiment run in microgravity and run on Earth, okay? So this was quite complicated because at the end, they had to make all the circuitry to automate the experiment. So it took longer than they anticipated, and they had to find extra funding to actually build the automation electronics. At the end, they were able not only to do their experiment, but they also fabricated an electrochemistry device to be used for any other electrochemical experiment in the ISS. And they published this paper recently on that particular experiment and how to mitigate the issue of why this electrochemical reaction is is slower in microgravity, how to avoid that problem, and they publish in the Microgravity Journal, which is a member of the Nature journal family. So that was in 2020, although it was published only recently. Then we had el primer satélite boricua by Dr. Amilcar Rincon from Inter-American University, and he's here, yes, please. It got a lot of publicity in Puerto Rico and in Orlando, where we have like Puerto Rico West. So Dr. Amilcar Rincon wrote one of these proposals. He wrote one of these proposals more recently. This particular experiment was initially funded by a space grant. Over time, over years, he had with his students been doing payloads for BalloonSat, for the HASP, which is the high altitude balloon, and then he wrote a proposal to another program in NASA which is called ELANA, which is for launching experiments in the ISS, and he won that proposal, and combining ELANA and space grant funding, he was able to build this satellite in collaboration with UCF, where they were doing particle collisions in microgravity as a means of studying the formation of planets, or before planets, how you call it, ¿cómo se llama lo que no es un planeta? Los asteroides. The formation of asteroids and planets through the study of the particle collisions in microgravity. So that's the kind of experiment that he brought into the ISS in 2021, which was named the Satélite Boricua, or the Puerto Rican satellite. Then we have another project that was launched in 2022 by Dr. Eduardo Nicolau in UPR Rio Piedras. This is another chemistry experiment. In this case, he is demonstrating the use of forward osmosis for the water reclamation in the ISS. And there are a number of advantages of forward osmosis versus reverse osmosis, which is more typically used in these space applications. And actually, the agency is considering forward osmosis and these membranes of Dr. Nicolau for the Artemis mission. So, and that's a different project that now he's taken with another NASA project that he wrote directly to the agency. But let's talk about the ISS project. They developed these membranes for forward osmosis, and they wanted to test it under microgravity conditions because they were looking to see if they would be useful for space applications. We know already that they work on Earth, so would they work also in microgravity? And they launched this experiment recently, and they demonstrated that the membrane for forward osmosis works perfectly well in microgravity as it does on Earth. And that's how they validated this particular technology for space applications. And actually, you have here a picture of the astronaut who was activating the experiment in the ISS, and the agency decided to do like a highlight of this experiment in their website. And now, more recently, Dr. Amilcar Rincon wrote a proposal to the Puerto Rico EPSCoR ISS funding opportunity, and he won. You know, again, it's a two-tier process. He won the local competition, and then we sent his proposal to the national competition, and he won also he was selected at the national level to submit another payload to the International Space Station. In this case, it's also related to asteroids, but in this case, it will be measuring the speed of light, the speed of sound under different, for different kinds of simulants of asteroid material, for different particle size. And he will be doing those, again, those experiments on Earth and doing those experiments in microgravity as a means of collecting data that will help us characterize better the asteroids. I don't know if you have been following up the news about the asteroids, but NASA is very much interested in asteroids. They are going to study a metallic asteroid. They have a mission for that. They studied Bennu. They took samples from Bennu back to Earth. They sent a spacecraft to hit an asteroid and deflect the trajectory of the asteroid. So NASA has been very active in doing asteroid research. And one of the things that they found when we tried to change slightly the trajectory of one asteroid is that the composition of the asteroid was not what they anticipated. So the collision that took place was not what they anticipated. And the amount of deflection, of course, was not the amount of deflection that they had anticipated. It was actually much more than they had anticipated. So, how to learn more about the asteroids by doing characterization, remote characterization is an important topic for NASA, and Dr. Rincon will be helping NASA in that particular aspect of the asteroid research. So this is a diagram of the payload that they are building in the Inter-American University. Some of the students who are working on the project, and also we got the visit of our technical monitor last summer and the year before, Dr. Mitch Krell, who comes to learn firsthand about the progress of Dr. Amilcar's Rincon project. And there is another project that was not submitted under the NASA EPSCoR ISS, but is a project that received funding from the Research Award of Puerto Rico NASA EPSCoR by Dr. Thorsten Stelzer from the Medical Sciences campus. He's developing a way to do continuous crystallization in microgravity as a first step to develop, to be able to synthesize medicines in space. Okay, why is this important? Because if you send people to Mars, you won't be able to provide medicines, continuously to them. So you cannot take all the medicines with you, and also medicines will expire eventually. So you need to have a way of synthesizing medicines and other chemical products on site. And so he's developing this continuous flow crystallization instrument that he already knows it works on the bench, and now he wants to see how it works in micro. And it has been developing, taking into consideration the complications in microgravity so that it should work in microgravity. But the only way to know if it works or not in microgravity is by testing, by taking it to the ISS and testing the machine there. So he recently submitted a proposal directly to the ISS Notice of Funding Opportunity, together with some implementation partner here, Rhodium, and this proposal is right now under consideration by the agency. And I just want to say again that I mentioned before that one of our Notice of Funding Opportunities is open for the pre-proposal stage in Puerto Rico. You can go to submittable.com and look for Puerto Rico Space Grant or Puerto Rico NASA EPSCoR. If you can find under both of them, it's open until December 15, and there will be a new NASA EPSCoR ISS Notice of Funding Opportunity that will open in January. So just in a few weeks from now, we'll open a new Notice of Funding Opportunity. Will run a local competition in Puerto Rico, and you can be one of those who apply and get the opportunity to submit the proposal to NASA for the 100K. These are the criteria that they use for vetting those proposals to the ISS. You can guess what they are. Power requirements, size, mass. So those constraints have to be in check for your proposal to be selectable. And of course, funding, that the 100K should be enough to complete the experiment and build the payload to be sent to the ISS. And with that, I finish. Thank you very much.